go back into like trig and pre-cal?
Totally up to you, and Dad. I'll figure it out together. I mean, kind of
Okay.
depends how many days a week you want to meet, and
Mhm.
how much practice you want to do on your own. I know sometimes summer it's not the most exciting thing to do a little bit of math, but the more
Yeah.
you do, the better it is long term. So staying
Okay.
engaged. I mean, I'm not one of those going to give you a lot of work. I'm going to suggest doing problems, but that's totally up to you.
Okay. Sounds good. Thanks.
All right. So let me stop my video here. And we'll just go ahead and get started. This is a right triangle. You've probably seen this before, A, B, and C. Do you remember the relationship between A, B, and C in a right triangle?
A squared plus B squared equals C squared.
Yes. Now, very important is that you recognize that A and B are the legs. The legs come out from the 90. They're smaller than C. Some students even remember like leg squared plus leg squared equals hypotenuse squared. Okay. So for example, let's say I give you a problem where I tell you that this is 6, 8, and I ask you to find the value of C. Could you tell me that?
Um,
So here's what I'm
100.
asking for. So yeah, closer. So it's an A squared plus B squared equals C squared problem. And A is 6, B is 8. So what you just gave me is the value of
Oh,
C
wait, it'd
squared.
be 10.
It would be 10. Now, why isn't it negative 10? Because when you take the square root of C squared, square root of 100, it's plus or minus 10. Why isn't it negative? Any
Because the
ideas on that?
distance can't be negative.
Exactly. Good. Okay. So that's a good start here. Let's look at another triangle. There's just a tiny bit of feedback. I don't know if your volume is up a little too high, but it's okay. I'm not all right. Could you find a C for me in this problem here, please?
Yeah. Um, 13.
It is 13. Good. All right. So here's a new style of problem. So I don't always have to give you just the two legs. I can give you a leg and a hypotenuse. In this case, I give you a leg A and hypotenuse C. And
Yeah.
for our lessons, I mean, doesn't bother me if you use a calculator. I'll even give you a link to a scientific calculator online that I like. That's not important to me. What's important is you getting the right calculations, not being slowed down by them. So I know at some point students just don't know the squares of 17 or 15 or other numbers. So but this one's a little bit different. It's A squared plus B squared equals C squared. I'm not giving you A and B, I'm giving you A and C. Could you try solving this for me, please?
Yeah. Is it 8?
It's 8, good. So up until now, I've been giving you what are called Pythagorean triples. The first one is a 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. And these actually go on forever. There's actually an infinite number of them. And the ones I've written here are the ones you most commonly see on standardized tests. They're also used in math, science, and engineering classes because they work out nicely, especially when you're doing problems by hand. There's also what's called multipliers and divisors. So if you take and multiply, for example, let's say you multiply this by 2, 6, 8, 10, that also works. But you can also do something really, which you might not think to do, but divide by 7. And 3 out of 7, 4 out of 7, and 5 out of 7, those also work.
Okay.
I'm assuming you've seen this before because this would have been covered in geometry or the nice numbers, but these go on forever. You should remember some of them, but not all of them. There's a point where it's just like, it's too much.
Mhm.
But reality is that you're not going to get all of the nice problems. They're not always going to be nice, and that's what we're going to look at next here. So here's a new problem. This time A is 6, B is 3. So when you take A squared plus 3 squared equals C squared, you get 45 equals C squared. Do you remember how to reduce a root like this?
It would be the square root of 45, and then you could do 5 times 5 times. Well, you could do 5 times 5, and then
So 5 goes into 45, but not 5 times. It
oh,
goes in
9. So it'd be 5,
9
9, and
times.
3. So 3 and 3.
Yes. So
And then you'd bring the 3 out, so it'd be 3 to square root of 5.
very good. I'm hearing really good stuff so far. No obstacles yet to be able to solve these types of problems. That's really good here. Let me throw one at you here for you to look at and work out here. So I've made the numbers a little bit larger. I recommend using a calculator if you need to get the squares of those, but this one does require you to reduce a root.
Okay. Uh, 3 square root of 58.
Oh, how would you assess the difficulty of that problem?
It was simple.
That's good to hear. Okay, so we're going to switch to more special triangles. Okay, and what again should have been covered is 45, 45, 90 triangles, and then 30, 60, 90 triangles. Do you remember either of those designations and what they refer to?
Yeah. It's
Fantastic. Go ahead.
I was just gonna say it was like the angles inside the triangle and how they correspond.
Exactly. 45, 45, and 90. The two legs are the same. It's isosceles. And then the reference triangle tells you that the two legs are the same. And then the hypotenuse is the leg times the square root of 2. And these are the easier types of problems that you'll see. But it would look something like this. I would give you a problem and say, let's say the side length here is I'll make it a little more difficult, 2 square root of 6. And it would ask you to solve for A and C. Could you tell me the value of A and C?
Um,
So the two legs are the same, absolutely the same.
so then A would just be 2 roots.
C is a little bit more difficult. If you recall from the reference triangle, you take the leg and you multiply by the square root of 2 to get the hypotenuse.
It would be 4 root 3.
All right, now let's do another here. Do you typically, well, let me ask it differently. What kind of grades have you been getting in math lately?
Typically like high B's, low A.
Okay.
Our school's like kind of different because we do 2 math a semester and I do honors, but it's like so you have one math class for like 5 months and they condense all the material into like those 5 months and you have your midterm and final during then. So it's a lot more fast paced.
Yeah, it's more like what you'll see in college.
Mhm.
So that could be good if you're ready for it. All right, here's a new problem. I'll draw the reference triangle if you need it. It's x root 2. I'm kind of going to the extreme end of the difficulty because you've been able to do these problems. So uh, I don't know if you will have trouble with this, but give this a try. Ask me some questions if you're not sure.
Here you just like divide by root 2.
Exactly. Yes.
Oh, okay. So you just divide the ins.
Yeah, I didn't hear anything. So that's sometimes you'll see me jump in and just start writing some things. Yes, you divide the inside part here, and sometimes you get something that is reducible or not. We don't really know. Um, so let's have you try one more like this.
(15 root 13).
So the other type of special triangle that you'll see is what's called a 30, 60, 90 triangle. Do you remember if the 30-degree angle goes at the top or the bottom here? And assume it's drawn to scale, uh, meaning that
Top.
that yes. Why is it up top? What does the angle tell you about the side?
Um, could you like rephrase that?
Sure. I didn't ask it well. I'm just going to give you the answer because I don't know how else to ask it. The smallest angle corresponds to the smallest side. The largest angle corresponds to the largest side. So the one in between is the one in between.
Okay.
And so the often this is referred to as the short leg down here, and then the long leg over here. And the short leg is x, the hypotenuse is 2x, and the long leg is x root 3. So there's 3 possibilities here. Possibility number 1 is that you're given x, or you can find the short leg, like it's either given or somehow you can get you can you can immediately find the hypotenuse 2x or the long leg x root 3. You agree with that? Do you see how you could do that very quickly?
Yeah.
So that's when you're given the short leg. The other possibility is you could be given the hypotenuse, the 2x. So from the hypotenuse, you have to find the short leg next. Let's say I give you the hypotenuse and it's 20. What would the short leg be?
10.
10, because you divide by 2. You get the short leg. Then you can
Yeah.
find the long leg. So there's a path. There's a path here. You have to follow this path. The other
Mhm.
possibility is that you're given the long leg. You're given the long leg over here. Your only path is to then find the short leg. And it's kind of like what you were doing in the previous problems. You set the long leg equal to x root 3. You solve for x to get the short leg, and then you can find the hypotenuse. Does this all sound familiar?
Yeah.
Okay. So let's try some problems and see where you're at on this one.
Uh, wouldn't you just be 20 times 20 root 3?
For which one?
Oh wait, no, you would be 5 root 3.
Okay, I agree.
And then V would be 5 root. 5 would V would be 15, right?
Okay. Okay. What do you feel like was difficult about that? What's the
Uh, I got a little, it was like kind of confusing, like trying to remember how each of them like correlate and like dividing and multiplying
yes.
properly.
So a really good strategy is to always draw the reference triangle. X, 2x, x root 3. And since you're given this side, I call it this, you're setting the known side equal to the reference side. And what I mean by that is you're setting 10 root 3 equal to 2x. And from there, you can solve for x, short leg, get the other things. Okay. Good job on that. Let me grab another problem here for you to try.
Okay.
Yeah. All right. Go ahead and take a look at that, please. And if you need me to, I'm happy to draw the reference triangle.
Okay. B is 4 root 5.
Okay.
C is 8 root 15.
Good. So not too bad when you kind of have the
Yeah.
down. All right, so let me grab one more. Doing great. This is it's nice to work with a student that's, kind of like I don't have to explain everything every step. We can quickly move through like 4 topics in a short amount of time. And I think it's because you've seen all this before, which is great to hear. You remember it, and I think that's awesome. So give this one a try, please.
F is 4 root 2. And then G is 8 root 2.
Now, I want you to tell me, does this still hold?
Can I use a calculator on this one?
Well, let's do it by hand, but I guess what I wanted to know is, do you think the Pythagorean theorem still holds even with all this mess?
Yes.
Yes, it does. And so let's quickly talk about how to actually square these things, so you can get a feel for that. 'Cause that's something you should be comfortable with. So when you square a number, that just squares. The square undoes the square root. So this is 16 times 2, 32. 4 squared is 16 times 6 is 96. And then this is 64 times 2, 128. Does this work?
Yeah.
Yes, and it should. It should. The idea here is that all special triangles, all triangles, right triangles, they always adhere to this. You know, this is always going to work. So last kind of thought here before close out here, but let me give you something pretty simple here. Do you remember how to find the value of sine A, cosine A, tangent of A?
Yes.
You may have seen something like this.
Yeah, that's what I use.
Could you tell me? Could you tell me what sine of A is?
Sine of A would be 4/5.
Okay, and how about cosine of A?
3/5.
Good. Tangent of A?
4/3.
Good. Now let's say I added B there. I'm just gonna move these over a tiny bit. Sorry, that's not what I meant to do. Sine B, cosine B, and tangent B.
Sine B would be 4/5 again. Oh,
So
wait, no, 3/5.
yeah, you're repositioning, you're adjusting opposite is now there. Good.
Yeah.
How about cosine B?
4/5.
So do you notice, and this is important, that these are the same and these are the same?
Oh, yeah.
Now it doesn't work that way for tangent. They end up and tangent, they end up being reciprocals, but there's a lot of stuff in trigonometry like this where there's these sort of relationships that if you can remember and leverage, you can do really well in the class. So good. Okay, so we're gonna go ahead and stop right here for today.